Today's lesson is on reasoning with properties from algebra, and I know I said to you on the day we did deductive reasoning that we were going to get down to the nitty-gritty. Well, today we're really going to get down to the nitty-gritty because we are going to do our very first proofs. So we're going to start with the properties of equality, and you were tasked with making flashcards for these, so I'm going to go through this pretty quickly. Guys, you got to know these. You got to know them like the back of your hand. So study those flashcards. All right. So if A equals B, then A plus C equals B plus C. That is the addition property of equality. All right. For the second one, if A equals B, then A minus C equals B minus C. Essentially, it's just subtracting the same number from both sides of the equation, and we've been doing that for a long time. And so that's the subtraction property of equality. All right, if A equals B, then A times C equals B times C. Of course, that's the multiplication property of equality. And then if we divide both sides of the equation by the same number, that's the division property of equality. All right, for any real number A equals itself. That's what's known as the reflexive. You may be thinking, why in the world do I need to ever say that some number equals itself? Well, you'll see that when we're doing proofs, there are often times when we do need to do that for the purpose of making a logical argument. All right, what property is this? If A equals B, then B equals A. If I just switch them around, that's the symmetric property of equality. And if A equals B and B equals C, then A equals C. That doesn't show up on my board. I don't know if it showed up on your paper, but that is the transitive. Remember, it's kind of like the law of syllogism, transitive property of equality. And if A equals B, then I can replace anything in any equation with B. If A equals, I can replace any A with B if A equals B. That's the substitution property of equality. As I said, you've been using these properties for a long time since you started doing Algebra 1. And finally, this property here, where I distribute the A to everything that's in parentheses, is called the distributive property. So those are all properties of equality. What I do want to point out to you here is that these three properties, reflexive, symmetric, and transitive, these are also properties of congruence. We have these properties of congruence also. I'll touch on that in our next lesson, but I just thought this is a good time to point that out. We will use these so much in our proofs. All right, so now that we've got all the theorems we've ever learned and the definitions and postulates and these properties, let's just hop right in here and do a proof. What is a proof? A proof is a convincing argument that uses deductive reasoning. Remember, we're not going to use inductive reasoning, which makes an argument based on patterns. We're going to use deductive reasoning that uses facts and given statements to logically show why a conjecture is true. There are three types of proof. You can have a paragraph proof, a flow proof, two-column proof. I only do two-column proofs in my class. When I was in college and studying engineering, I never had to do a paragraph or flow proof. So I would ask you in the worksheets that I give you in your packets, and if you're doing problems from your textbook and it says do a paragraph or a flow proof, please always do a two-column proof for me. Your quizzes and tests will only have two-column proofs on them, no paragraph or flow proof. Okay, so let's practice. First thing we're going to do is we'll have our statements on the left and our reasons on the right. And sometimes when I give you a proof, there won't be a box there. There won't be a gray box. You'll have to set it up yourself. Yeah, there may be, I probably have, yeah, the next one we'll set up, so I don't need to write this over here. Okay, but we got a box here. We're always going to put our given statement first. So that's what's in our given statement first, and our reason is just going to be given. What I'm doing in the reasons column is I'm just putting how do I know that I can make the statement that I just made on the left-hand side. So that one's given. Okay, so step number 2 says, okay, well, it logically flows from step number 1. How do I know? How did I get from step 1 to step 2? What did I do? I subtracted that 1, right? I subtracted that 1 from both sides. So that's the subtraction property of equality, and I'm totally fine with you using abbreviations. All right, I would ask you to please not use cursive writing. Even if you have a beautiful, beautiful penmanship, it's very hard for me sometimes to read cursive. So just go ahead and print and feel free to abbreviate. Okay, and finally, how do we get from step 2 to our last step here, which is what your last step in the proof will always be the step that you're trying to prove. So at a minimum, if you don't know anything else, you can always get your first step and your last step, your first statement and your last one correct, because the first one is the given and the last one is what you're trying to prove. Okay, so what did we do to get from step 2 to step 3? Well, we divided both sides by 3, right? So this reason is going to be the division property of equality. And that's it. You just did your first proof. Congratulations. Let's do another. That was fun, right? Let's do another one. Okay, so there's no table here, so we're just going to set it up ourselves. We're going to put our statements on the left. We're going to put our reasons on the right, always. And I like to underline those. Just kind of keeps things organized for you. And we always number our statements and reasons. And like I told you, we're always going to put the given as our first step. So negative 2x plus 1 equals 56 minus 3x. And what's the reason for that? It's given to us. They told us that part is true, so that's how we know that. Okay, so let's see. We're trying to get down to what x equals. X equals 55. So what can we do here? How about if I add 3x to both sides? What's going to happen is this is going to become x plus 1 equals 56, right? If I add 3x to both sides. So my reason would be addition, property of equality. And finally, if I subtract that 1 from both sides, I'm going to get x equals 55, which is just what I was trying to prove. And what did I do? I said I subtracted the 1 from both sides. So that's the subtraction property of equality. And that's it. There's our second proof. You guys are awesome. Okay, here's another one. I think what you should do right here now, this is similar to the other two that we did, so why don't you pause right here and try to do this proof on your own, and then you come back and I'll have it set up for you. All right, so I set up my statements and reasons columns. Of course, I wrote the given here in step 1. Step 2, what did I do? I just applied the distributive property. So of course I list that as my reason here. Okay, so this may be the point where you didn't know what to do because we did not have a step like this in our previous two proofs. So what I did here is I combined the like terms, 12x minus 3x, and I got 9x. So for this reason on number 3, you could write combine like terms. You could also use simplify as a reason. You could have also, listen to this, you could have also used as a reason substitution, because what did I do? I substituted in 9x for 12x minus 3x. So probably the very best reason that I could put there for that step would be substitution, but I oftentimes write combine like terms, and that's perfectly acceptable. Okay, and once I'm down to that step, 9x minus 21 equals 8x, probably you guys, you feel like you want to say, okay, well, x equals 21. But remember, when we're doing a proof, we can't do two steps at once unless they have the same reason. Okay, so what I had to do is I had to subtract the 8x from both sides to get to step number 4. So there was my reason for that. And then I had to add the 21 to both sides to get to step number 5. So even though if you were doing this, just doing an algebraic problem, you could have easily gone from step 3 to step 5. You can't do that in a proof because the two reasons aren't the same for those steps. So you got to be careful there. And you're going to find that tedious when you know it in your head, but you have to write every single step. Remember, it's like doing a proof is like trying to give someone directions to somewhere. If you leave out one turn or one street name or something like that, the person is not going to get where they want to go. So it's kind of the same thing with the proof. Okay, so these properties that we just learned, we can also apply them to segment and angle measures. So the reflexive property for segment AB is just going to say if I got a segment AB, then AB equals AB. And again, you'll figure out why in a little while why we need the reflexive property. For any angle A, oh sorry, I made a big mistake. I hope you caught me. I'm talking about length here, so I want to use AB equals AB, not segment AB. That's a big mistake. For any angle A, the measure of angle A equals the measure of angle A. Symmetric property says that if AB equals CD, then CD equals AB. And for the measures, that would say the measure of angle B equals the measure of angle A. And finally, the transitive property of equality here would say that AB equals EF, and the measure of angle A equals the measure of angle C. All right, so there are your properties applied to segments and angles. So let's do another proof. I'll do this one and then I'll let you work on the next one and we'll go over it at the beginning of class because I don't want this video to run too long. Okay, here we go. Use a two-column proof. So I got my statements over here. Got my reasons over here. First statement, of course, is going to be, I have two given statements. So when you have two given statements, you can write them in the same step or you can make two steps. It really doesn't matter. So I got the measure of angle 1 plus the measure of angle 2 plus the measure of angle, plus the measure of angle 4 equals 360 degrees. My reason is that's given. Okay, I'm just going to put the second given one right down here. Measure of angle 2 plus the measure of angle 3 equals the measure of angle 4. So like I said, you could make that step 2 and then your number 2 reason would be given, but as long as you're using the same reason, you can leave it as one step. Okay, so, oh my gosh, there's another one. Here's another given statement. I'll just add that one right there. Measure of angle 1 equals the measure of angle 4. So that's given. So wow, all that is right there together. So now, what am I going to do? Well, it looks like to me I'm going to need to use some substitution, right? They've given me all these different angles that are, their measures are equal to each other. So I'm, sometimes in a proof, guys, you have to just start writing down steps that appear to logically flow, and then you may find out that they're not really getting you where you want to go. That's why you need a good eraser. There's no shame in that, no problem with doing that. I do it all the time. I start writing down what seems logical, but then it turns out I'm not getting where I need to go, so I just backtrack and do something else. So what I'm going to try first here is, since the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4, I'm going to substitute measure of angle 4 right in there, right? I'm going to substitute that right in there for the measure of angle 2 and the measure of angle 3. So here's what that's going to look like. So I'm not changing the first part. I'm saying the measure of angle 1 plus, here's where I'm going to do my substitution, measure of angle 4 plus the measure of angle 4 equals 360. and that was substitution, property of equality. Okay, now let's see, what can I do now? Oh, look, I know that the measure of angle 1 equals the measure of angle 4, so I'm just going to substitute that in for both of these measures of angle 4, right? So my third step is going to say the measure of angle 1 plus the measure of angle 1. There's my substitution. I'm going to do another substitution. Measure of angle 1 equals 360. Substitution, property of equality. So now, what can I do? Oh, I'm going to add all these together. So that's going to be 3 times the measure of angle 1 equals 360 degrees. And once again, I'm just going to use my old standby reason, combine like terms. All right, and I didn't leave myself enough room here to get my 5th step in, so I'm going to just bring it right over here. Hopefully you got room on your paper. So number 5 statement is just going to say, what is it I'm trying to prove? Measure of angle 1 equals 120. And the reason, so that's the statement. The reason, sorry, this is a terrible way to do this, and I really hate that I had to do it. Didn't have room. The reason, what did I do to get from step 4 to step 5? Well, I divided both sides by 3, right? So that would be the division property of equality. And there it is. There's my proof, 5-step proof. Go over that again. Highlight it if you think we need to talk about it some more tomorrow. And now your homework is, in addition to looking at these notes and making sure you got it, I want you to do this proof. This proof number 2 here, I will tell you that I put my 2 given steps as step number 1, statement number 1, and then it took me 4 steps to do this, so hopefully you should be able to do this in 4 steps. Give this a try. I know it's new, I know it's kind of tough and scary, but give it a try, and then we'll go over this at the very beginning of class next time.